A strip footing 1 meter wide at its base is located at a depth of 0.8 meter below the ground surface. The properties of the foundation soil are cohesion 30 kN per meter square, angle of internal friction 20 degrees, and unit weight of the soil 18 kN per cubic meter. Determine the safe bearing capacity using a factor of safety of 3 if the water table is located at the base of the footing. Take saturated unit weight of the soil as 19.5 kN per cubic meter. Use Terzaghi'S analysis and assume local shear failure. In this problem, a strip footing is given. Its width is mentioned as 1 meter. Its depth below ground surface is 0.8 meter. Properties of the soil, those are given here. At the same time, saturated unit weight is given, that is 19.5 kN per cubic meter. Here we want to find out safe bearing capacity. The factor of safety which is mentioned is 3. One more condition is given, the water table is located at the base of the footing. So that means water table is located at what distance? It is at a 0.8 meter depth from the ground surface. Also, we have to assume local shear failure. We have to show all these details on the diagram. In the diagram, we can see this is strip footing. Its width is 1 meter and depth of the foundation is 0.8 meter. This is ground surface and water table is located at the base of the footing. So base is at a 0.8 meter depth from the ground surface. Hence, this line is going to be the water table level. Okay. Hence, ZW1 will be equal to DF and ZW2 equal to 0. What is ZW1? ZW1 is depth of water table from the ground surface and ZW2 is the level of water table with respect to base of the foundation. Hence, ZW1 equals to DF and ZW2 equals to 0. That is what is mentioned here in the data. Properties of soil: gamma 18 kN per cubic meter, gamma saturated 19.5 kN per cubic meter, cohesion 30 kN per square meter, angle of internal friction 20 degree, factor of safety 3, local shear failure condition, width of the footing 1 meter, depth of the footing 0.8 meter, ZW1 0.8 meter and ZW2 0.00 meter. Our first step is to write down the equation for ultimate bearing capacity for Terzaghi'S analysis. Ultimate bearing capacity for strip footing is found out using this formula. QU equals to CNC plus gamma DF NQ plus half gamma B and gamma. Here local shear failure condition is mentioned. Hence, for local shear failure, bearing capacity factors NC, NQ and N gamma would be written as NC dash, NQ dash and N gamma dash. Secondly, cohesion, that is C, is taken 2/3 of its original value. Hence the equation has become 2/3 CNC dash plus gamma DF NQ dash plus half gamma B and gamma dash. Here condition of water table is also shown. Therefore, the second term would be multiplied by reduction factor RW1 and third term will also be multiplied by reduction factor RW2. So our first job is to find out RW1 and RW2. Reduction factors for water table, those are written as RW1 and RW2. RW1 is calculated as 0.5 multiplied by square bracket 1 plus ZW1 upon DF square bracket complete. In this equation, ZW1 is depth of water table from the ground surface, which is shown in the diagram, and DF is depth of foundation. Therefore, this is equal to 0.5 multiplied by 1 will be written as it is. So 1 plus ZW1. ZW1 is equal to depth of foundation, which is 0.8 meter, because water table is located at the base of the footing. And what is DF? It is the depth of foundation, hence 0.80. Alright. 1 plus, now this 0.8 will get cancelled, so it will be 1. So 1 plus 1, 2. 2 multiplied by 0.5, it is going to be equal to 1.00. So RW1 is equal to 1. Similarly, we have to find out RW2. RW2 is reduction factor which is connected to the elastic wedge which lies below the foundation. Alright, hence it is written as 0.5 multiplied by 1 plus ZW2 divided by capital B. Here this will be written as 0.5 multiplied by 1 plus ZW2 is the depth of water table below the base of footing. Here water table is located at the base of the footing. Hence ZW2 is equal to 0. So ZW2 is substituted as 0 divided by B. B is width of footing, which is 1.00 meter. Thus 0 divided by 1, it will be 0, plus 1 is going to be 1. This one multiplied by 0.5 is equal to 0.50. Thus reduction factor RW2 will be 0.5. In this way we have obtained reduction factors RW1 as 1 and RW2 as 0.5. We have to substitute these two values in this equation. Thereafter we have to find out parameters NC dash, NQ dash and N gamma dash with respect to this value of phi, which is 20 degree. Here local shear failure condition is mentioned. Hence we have to refer the chart and accordingly we have to select the values for NC dash, NQ dash and N gamma dash. Thus from the table, for phi equals to 20 degree, NC dash, NQ dash and N gamma dash values are 11.8, 3.9 and 1.7 respectively. Here directly local shear failure condition is mentioned. Hence there is no need to modify the value of phi. Now we will substitute all these values in the basic equation of ultimate bearing capacity. Thus in this equation QU equals to 2/3 of C NC dash, that is cohesion multiplied by NC dash 11.8 plus 1 multiplied by 18 into 0.8 multiplied by 3.9. What is 1? 1 is the reduction factor for water table. Recently we have found out. So this is the value. RW1 is 1. Alright. Thereafter, this is gamma. Gamma is unit weight of the soil. Which unit weight? This particular term is related to soil which is lying above the base of the foundation. Alright. So above the base of the foundation, the soil is moist, and below the water table or base of the foundation, the soil is saturated. How is it possible? Because water table is located at the base of the footing. Hence, soil above water table will be moist soil and soil below water table will be saturated soil. Therefore, in the second term, we have used this 18 value, which is related to unit weight of the soil in moist condition above water table. This is multiplied by DF, that is 0.8 depth of footing, multiplied by NQ dash, that is 3.9. This third term is related to the elastic wedge which is lying below the base of the foundation. And as we know, water table is located at the base of the foundation. This particular soil will be saturated soil. Hence, while substituting value of gamma in third term, we have to use saturated unit weight of the soil. Alright, so the term becomes half gamma B multiplied by reduction factor multiplied by n gamma dash, that is 1.7. Alright, so gamma is going to be 19.5, B width of footing is 1, 0.5 it is the reduction factor which we have recently found out, and 1.7 is n gamma dash. Solving this, we will be getting ultimate bearing capacity of the soil. Thus Qu comes out to be 300.44 kilonewton per meter square. The next step is to find out net ultimate bearing capacity. Qnu equals to Qu minus gamma dF. Qu is ultimate bearing capacity, gamma dF is surcharge. Hence, this is written as 300.44 minus value of gamma will be connected to this height. Okay, hence it is written as 18 multiplied by 0.80. So this unit weight is related to unit weight of the soil above the base of the foundation. Hence we have used 18 as gamma. From this we will be getting Q and U. It comes out to be 286 kilonewton per meter square. Next step is to find out safe bearing capacity of the soil. It is found out at Qs equals to Q and U divided by factor of safety plus gamma multiplied by dF, which is equal to 286 divided by factor of safety is 3 plus gamma is 18, dF is 0.80. From this we will get value of Qs. Qs comes out to be 109.73 kilonewton per meter square. This is the answer. Thus, by considering water table at the base of the foundation, safe bearing capacity of the soil for strip footing is calculated.